Hello, I just wanted to make a quick video to go over how to do some of the questions in equilibrium. So here we are. This is a question that is best done with the sine law. So to do that, we're going to need to build a force triangle. Now we have three forces. We've got our gravity, that's down. We got our T2, that's in that direction. And we got T1, that's in this direction. T1, T2, and mg. Now, the first condition of equilibrium says that our forces have to cancel. So we could either like find all the upward components and downward components and say they have to equal each other, and left and right components say they equal each other, or we just treat these like vectors and say, hey, if we do a little diagram where we add all these vectors tip to tail, we should end up right back where we started, and that'll give us a triangle. So that's what I'm going to do. With situations like these, I like starting with gravity. So I got my little gravity vector here, and then just arbitrarily, I'm going to pick T2 to go on to next, largely because I wrote my mg here, so I want to give some space for the next line. So I'm going to start drawing perfectly an arrow going off in the T2 direction. So this will be 20 degrees because it goes off 20 degrees to vertical. That is T2. And then I just stopped here because I figured if I started drawing a vector in the T1 direction, I'd come back to where I started. Now, I know that this angle is 15 degrees. Sorry, that's pretty garbage, but this angle is 15 degrees right there with the horizontal. I also know if I drew another horizontal here, due to alternate interior angles, I've got something that looks like a Z. This would also be 15 degrees. Now, I've also got a vertical line here and a horizontal line. And if you've got a vertical line and a horizontal line, obviously there's 90 degrees between them. It's perpendicular. I've used up 15 of that 90 right here, which leaves a grand total of 75 degrees for this point. And then I've got two of my angles, and I know my angles here have to add up to 180, so I can figure out this guy. 75 plus 20 is 95. So I've used up 95 of my 180, leaving 85 degrees for this point right here. Now I've got all my angles. I know one of the sides, by the way, 15 times 9.8 to get this side is equal to 147. And so then I can find T1 and T2 just using my sine law. Basically the ratio of any side to the angle, sine of the angle opposite it is always the same. So I know this side and this angle opposite it, so I'm going to start with that. That's my known. 147 over sine 85. That is one of the ratios. And that is equal to either T1 over sine 20. It's also equal to T2 divided by sine of the angle opposite it. And the angle opposite T2 is 75. So I can then just rearrange this and do 147 times sine 20 divided by sine 85 has got to equal T1. That's not so bad. Once we've drawn the triangle, this is relatively easy given the difficulty of this question inherently. All right, so that's how you'd solve this question. I'm not going to run it in because that would just take up time, and it's just plugging stuff in your calculator. So yeah, that's how you solve something using the sine law. You could also do it with cosine law, depending on what you knew. Not this particular question, but a different similar question. So yeah, we just draw all our vectors tip to tail to make a little force triangle where we come back to where we started, and then use sine or cosine law to solve for what we need. That is how you do a sine law style question.